Okay, so we're looking at trigonometric functions, cos and sine. You can look for tan on your own, but essentially to say that if I want to differentiate cos x, that's equal to minus sine x, and if I want to differentiate sine x, that's equal to cos x. The proof is in one of the other questions. It's not applicable to this course because it's more of a high level, maybe degree level, rather than A level. But anyway, let's have a look at question 1. So, because it's one function times another, I'm going to differentiate, use a product rule. So I'm going to say f of x is that, and g of x is cos x. So f dash of x is 1. Differential of g of x, in this case we know, minus sine x. So using the product rule, where I multiply the two together, I can say that the differential of x cos x is equal to minus x sine x, them two multiplied together, and then these two multiplied together add cos x. Okay, and that's it. Number 2, I'm going to do the same thing. I'm going to say that f of x is cos of 2x, and that g of x is equal to 1 over x. Okay, I'm going to use the product rule because, again, I don't like the quotient rule, it's too messy. So f dash of x, in this case, well, I've got a composite function here, so I use the chain rule. So differentiate the inside gives me 2, differentiate the outside, cos x gives me minus sine, so minus 2 sine of 2x, differential of gx here, it's obviously negative, and then it's take one of those there, so x to minus 2. So if I put those in again there, so d dx of cos 2x over x, we can use the product rule, so these two multiplied together, minus x minus 2 cos 2x, okay, and then these two together, so minus, then minus again, minus 2x sine of minus 2 to the minus 1 sine of 2x. These have got both factors here, so I'm going to multiply through, or divide through, by x to the minus 2, just to make it so it's easier to deal with. And this gives me minus cos 2x minus 2x sine x, all divided by x squared, because remember x to the minus 2 is equal to 1 over x squared. Okay, so I've just put that over everybody just to make it a bit neater. You don't have to, you can have it like that. And the last one, 3, we've got f of x here is equal to e to the x, g to the x is equal to sine of x to the minus 1. It's not the same as the inverse sine. F dash of x is obviously e to the x, g dash of the x. Again, differentiate the inside, which gives us cos x. Differentiate the outside, which gives us times minus sine x to the minus 2, which in this case is minus cos x over sine x squared. So if I multiply everything together, which is those two again, so d dx in this case is equal to minus e to the x cos x over sine x squared plus e to the x over sine x, which is the same there. Now I'm going to do the same as I've done here. I'm going to multiply the top and bottom here by sine x, and that gives me minus e to the x cos x plus e to the x sine x over sine x squared. Okay, and then I can then say that I take a factor of that out and move that round there, and I get e to the x sine x minus cos x divided by sine x squared. Okay, Now that is using sine and cos. I've got one more question to do, but I'll put it on another video.